intensive crews both at Kennedy and at Edwards Air Force Base in California who will investigate the astronauts the moment they come back.
And you have some video, I think?
Yes, we have a video and it will show the advanced respiratory monitoring system during an exercise session. We see here Mike Anderson. And what we're doing here is that we determine the blood flow in the lungs and heart because he's breathing back and forth in a bag containing a gas mixture that is taken up by the blood flow. And then, in addition, we do study blood samples, lactic acid, and similar substances in order to study how much the exercise capacity is influenced by the absence of gravity. In focus now is a blood pressure monitoring system that will follow the heartbeat beat by beat without having to put a needle into an artery. It's a Dutch invention and it's used widely all over the world.
Okay, thank you, Dr. Lennerson. And let's now hear from Dr. Nicole Buckley on the Canadian Space Agency's Osteo experiment, one of the commercial experiments on SpaceHab on this flight.
Thank you very much. One of the greatest obstacles to long-duration manned space travel is the bone loss that astronauts experience in space. They lose bone at a rate 10 times that seen with postmenopausal women with osteoporosis. So we want to understand exactly what is the nature of bone loss occurring in space, and it provides an ideal laboratory to study this. And by understanding what's happening in space at this rapid rate of bone loss, this can help us understand what's happening here on Earth. Now, in the Osteo payload, we actually have 3 separate experiments. The first experiment is by Dr. Letitia Rao from the St. Michael's Hospital in Toronto. She will be flying bone cells and treating some of them with estrogen. She will then be comparing how the cells respond to estrogen treatment, which we know is a treatment that is used for menopausal women here on Earth to combat bone loss. So she's treating the cells with estrogen to see if this can combat the bone loss that is experienced in space. The second set of experiments by Dr. Reg Gorzinski from Toronto General Hospital takes a bit of a different spin on things. Dr. Gorzinski had previous experiments aboard Mir where he showed that immune dysfunction resulted in astronauts as a result of the sleep deprivation that they encounter in space. Now we know that some of the molecules associated with the immune dysfunction can also lead to bone loss. So what he is postulating and testing in this experiment is whether sleep deprivation can also promote the bone loss we see in microgravity. So to do these experiments, he again has cultures of bone cells in conditions where bone will actually be formed, and he is adding to some of these cultures the serum from sleep-deprived individuals. Now this serum will contain the immune molecules that would be elicited by sleep deprivation. And again, he's going to look at gene expression in these cultures when they get back to Earth to see what effect the immune chemicals can have on bone formation. The final experiment is being performed by a combination of industry groups, and that's Mr. Dennis Sindri and Dr. Brad Brinton. And Mr. Dennis Sindri had a previous experiment on board Osteo-1, which flew an STS-95 in 1998. Now, what they found in that previous experiment was that by treating bone cultures with intervals of parathyroid hormone, they could actually stimulate bone formation. And this experiment, they are again treating the bone cultures with parathyroid hormone, but this time they're looking at the gene expression to see exactly what effect the parathyroid hormone is having. So you see, basically, all these experiments are taking a different approach to looking at the cellular and molecular events that occur with bone formation and also with bone loss in space. Now, the hardware that we're using, I have an example of it right here for our Osteo. was designed by the Canadian company of Millennium Biologics. Now this is a trainer model for the Osteo-2 payload. Now you can see in the front these 4 dials, which are connected to 4 syringes. Now these syringes contain the reagents or constituents that the astronauts are going to add through these fluid pathways into one of these 3 modules. The bone cells are going to be contained in the different modules. By turning a different dial and pushing a button on the side, you can direct the contents of one of these syringes specifically to one particular module. And it's through this that we're doing the different experiments. For example, with Dr. Letitia Rao's experiment, 2 of these contain food for the cells, and in one of them we have estrogen. And in the 4th syringe, we have a fixative to finally close the experiment and preserve the cells so she can see and study them back here on Earth. Now, we also have pictures of the actual flight model with the astronauts. Now, here we see Commander Rick Husband and mission specialist Laurel Clark, who are doing our experiments up in space with, and you can see in between them, the Osteo payload. And in the next picture, you see Commander Rick Husband actually performing some of the manipulations to our Osteo payload. So I'd like to say that we've been very, very happy with this opportunity to combine industry interests and academic interests into a problem that affects astronauts and also people here on Earth. And also we're equally pleased to have an international cooperation with this project, since another example of this hardware has been lent to the European Space Agency to perform their bone experiments called Aristo. Thank you.
Thank you, Dr. Buckley. And as a reminder, at this time on Monday, we'll hear from Dr. Arnie Ferrando of the University of Texas Medical Branch in Galveston into his research on this mission on protein turnover in astronauts that affects the muscle structure of astronauts. And we'll also hear again from Dr. Tom Goodwin from the Johnson Space Center, who is going to tell us about bring us up to date on the cell growth in the bioreactor. You heard about that experiment early in our mission. That's all for now.
Okay, thanks, John, and your fellow briefers. We have no questions here at Johnson Space Center, so we'll go directly to Kennedy Space Center and take questions there. Please remember to state your name and affiliation before your question.
Hi, this is Chris Kreidler from Florida Today. My questions are for John Charles. Can you clarify which experiment it was that had the premature fixation, and maybe talk about what, if any, data was lost and if it can be duplicated?
That was the microbial physiology flight experiment. It's one of the suite of human life sciences investigations on this mission. And the procedural error resulted in the fixation of the control of the growth control yeast culture prematurely. It should have grown for a couple of days, and in fact the cells were fixed, and that terminates the experiment. So that was a control for some of the other investigations. That was a comparison study for some of the other cell preparations that are growing as part of that experiment. So that's going to make that portion of the experiment essentially inaccessible to the investigator, but he does have he's got 2 more card trays that are growing inside of the microbial physiology flight experiment incubator that he's hoping will still continue to provide some information, certainly not the entire set of information he had hoped for originally.
Which experiments were moved out of Space Hab, and what is the temperature in Space Hab right now?
The temperature in Space Hab is 77 degrees Fahrenheit, and the experiments that I'm familiar with that have been moved out include part of the microbial physiology flight experiment. The incubator has been moved to a cooler location, and also the readers that are used to assess or assay the astronauts' blood constituents when they do blood draws, which will be later in this mission, and also for sample checks of the bioreactor. That's called the PCBA, the Portable Clinical Blood Analyzer. Both the analyzer and the cartridges that are daubed with the solutions of interest have been moved back, I think, into the mid-deck where it's a little bit cooler, so they stay cooler and are preserved a little bit longer. Also in the human life sciences area, the tracers that are planned for the subsequent set of medical experiments starting on I think it's day 12 of the mission, have been put into the cooler to keep them cool, into the cooler where the samples are kept, to keep them cool and keep them viable for the remainder of the mission.
This is Phil Chen, Earth News. Let me follow up on that. How about the other biological stuff within the Space Hab module? I suppose both Florida, Houston, and Goddard would appreciate 77-degree weather, but how is the other stuff being affected? For example, the rats, stuff like that. Any concerns about the fact that they're kept much warmer than anticipated?
The rats have, like I told you earlier, the mufflers, the sound dampening agents on the front of the rat enclosures has been removed to facilitate the cooling, and those remain off while the temperatures are elevated in the module. The rat health checks continue to show the animals are just fine. The water consumption is not excessive, indicating they don't seem to be heat stressed. The crew is comfortable, so they're continuing to do their experiments. I think Dr. Lennerson mentioned earlier, if I can speak for him, that the ESA arms experiments actually exercising in the module are continuing despite any change in temperature. It doesn't affect their experiments as well. Am I quoting you correctly, sir?
Yeah, that's true.
Okay.
The ESA biopack, I understand it's been popping its circuit breaker and may have to be shut off for the entire mission?
No, I don't think it's a circuit breaker, Phil. I think the problem is there's the pressure sensor in the fan that's designed to keep the fan from being occluded and burning out if something occludes the airflow through the fan. And that pressure sensor turns out to be more sensitive than probably is appropriate for the situation. So occasionally when they open the door too fast on the device, they cause a pressure change. Obviously, if you open a closed box, you change the pressure inside as the air flows in to equalize or flows out. And that's been tripping the pressure sensor. That's happened several times, and I think that's the nature of the problem in that hardware, and they're working on a fix for that. That is, of course, an ESA experiment, and I'm not the ESA guy, so everything I say is secondhand on that.
And for the osteo payload, I seem to recall that on the STS-95 mission, when you previously flew, there was a similar problem in something getting fixed before actually done with the payload, so you didn't get data back on one of your or more of your runs, or am I confusing you with somebody else?
I believe that we did get results back from all the payloads in the STS-95. And also, I will say that we did have to do a premature fix because we had a little bit of a hardware glitch on one of our experiments on one of the trays. Each one corresponds to an experiment. But again, in this case, we didn't really lose any science, and we confirmed this with the PI beforehand. So we're all set. Our temperature is regulated at 37, so we're happy as clams.
Okay, I guess that's all the questions from Kennedy Space Center. Nothing more from here. A couple of programming notes about NASA TV before we conclude. During this briefing, we're probably going through the wake-up for the blue team. We hope to have a replay of that wake-up call for you when we come back with normal coverage. International Space Station Expedition 6 update is coming up at 3 p.m., followed by a replay of the NASA Educator Astronaut ceremony at 4 p.m. Central, and a replay of NASA Administrator O'Keefe's update at 5 p.m. Central. Finally, at 7 o'clock, we're going to start our replays of the Flight Day Highlights package. Thanks for coming today.